Right, Assalamualaikum, selamat pagi. Okay, we are going to start our class. Before we start, let's take a look here. Okay, so your first test will be conducted this week, and the test will be, the test will be, you are going to have two parts, part A and part B, where part A consists of 10 true and false, 10 multiple choice question, and for part B you are going to have calculation and short answer question. So for this test it will cover up until week 5 ni, chapter 5, work, power and energy. So there are calculation for that, there are calculation for others too, but the calculation is not that hard lah. It's just a surface calculation, straightforward. So make sure you read through from the introduction, maintaining equilibrium. Okay, underneath maintaining equilibrium ni kita ada equilibrium, principle of summation of force, and then we have what we call it, stability. So what is the ways in order to increase a person's stability, dekat sini. And then we go to linear kinematic, where underneath here we have velocity, acceleration, displacement, some calculation on that. Linear kinetics, we have introduction towards mechanical basis of human motion, which is Newton law. The first three Newton law, we have impulse momentum theorem, the calculation that relate impulse and momentum, where we have increasing of impulse, we are going to increase the momentum and vice versa. And finally, for chapter 5, we have work, power and energy, where we learn on explaining the formation of force based on work, power and energy equation. Saya rasa yang bawah ni, energy dia tak berapa banyak cerita lah, dia banyak cerita dekat work dengan power. Okay, other than that, you have soalan yang akhir ni nanti saya akan bincangkan di akhir kelas. It is regarding the first topic, measurement of mechanics. What kind of modalities that we can use in order to visualize kinetic and kinematic. Tu antara soalan-soalan dia lah. So please read through up until what we have learned from week 1 until week 5. So you have 10 multiple choice question and roughly 6 short answer. Okay, short essay. Alright, so that will be your test. Okay, soalan dia, bila kita nak buat test ni? Because the test will be 1 hour and 30 minutes. So I'm suggesting we conduct the test outside of our class hours. Selepas pukul 5 lah. We are not going to have class on Thursday, so we are going to use the same hours out of the class hour to conduct the test. The test is 1.5 hour. Bila agak-agak kamu nak buat? Sama dengan hari tutorial, which is Khamis, or you prefer to do it on Friday night? Ni nanti kamu bincangkanlah dulu. Okay, bincangkan dulu and then come up with me about the answer by today lah. Bila kita nak conduct test 1.5 jam. My suggestion will be conducting at night, and we are not going to have class on Thursday. Tutorial tu tak ada, kita gantikan dengan test. Boleh? Okay?
Boleh, sir.
Okay, nanti kamu bincangkan. Lepas tu WhatsApp saya. Okay. So for today, if we take a look at our scheme of work, today is week 11. So we have covered this topic. Okay, kita dah cover topik topik ni kita belum cover kan, applying biomechanical principle, qualitative biomechanic analysis to improve technique and training. Yang ni saya akan sentuh sikit towards the end of our class. Kelas kita tak panjang hari ni. This topic we have covered. Okay, we have covered angular inertia, angular momentum. We have covered motion in fluid, which is regarding drag and lifting. So today we are going to discuss about topic 10. Okay, mechanics of biological material, stress and strain on the body. Apa itu stress, apa itu strain, and then some sort of stress strain relationship, plastic behavior. But we are not going to cover this one as a whole. I'm going to give some time for you to study later on. Okay, so topic ini, this topic is actually subtopic for chapter kinetics. Okay, if you still remember earlier this semester where we are ni kinetics ni. Okay, daripada week 4 and week 5, where we talk about Newton law of motion, mechanical basis of human motion, F equals to ma, where we have forces which we can further explain the force in terms of inertia, in terms of mass, in terms of weight, in terms of impulse momentum, in terms of work power and energy. So now we are going to just take a look what kind of forces that always subjected to our body. Force jenis macam mana? Okay, so the force can be divided into two based on this topic, which is one is stress, one is strain. Ni dua je dia punya jenis. Okay, let's take a look at the concept. Alright, so for this topic, this is not your notes, but I already uploaded this one. For this chapter, chapter 10, you don't have notes. Okay, you don't have pre-prepared notes, but if you open up your classwork, saya ada masukkan satu tab ni, okay, dekat dalam preliminary reference book. So your reference book is the first one, this one, Biomechanics of Sport and Exercise by McGuinness. If you open up chapter 10, kamu akan ada topik ini. Saya bukakan chapter 10 dulu. So this topic, we are going to use this book. Ni, Mechanics of Biological Material, chapter 9. So we talk about stress and strain. So your main reference for this topic is going to be this book. So later on, just open up the book lah daripada dalam GC tu. You can download that. Okay. So before we start, when we talk about mechanical loads ni, it is actually a form of external force. Okay, a form of external force act on the body affected by the movement of the body. This is actually some sort of external force, not the force internally. Internal force being derived from the muscle contraction, okay, being proposed by muscle contraction. But all of this force, compressive, tensile, shear, later on kita ada bending, kita ada torsion, all of those force is actually external force inflicted to you. For example, kita ambil compressive force. Okay, so compressive force is caused by your weight towards your peripheral and axial skeleton. Berat badan kita yang menyebabkan compressive force. Tensile force, some of the action cause tensile force. It is not internal. First, you need to bear in mind that the thing that we discuss here, mechanical loads, means that all of this force, all of this type of force, all of these mechanical loads happen to be external. Okay, it happen to be external and acts to you due to your movement. So some of this load, if you are not moved, you don't going to have it. To mechanical load. Okay. Yang kedua, when you see mechanical loads, ni mechanical. Okay, mechanical, it means it is caused by some mechanism. It is caused by some mechanism. Mechanism apa? Kinetics, pergerakan. Okay. Alright. And all of this load impose or will affect the internal structure of the body. All of this mechanical load, it will affect your mechanical, it will affect your internal structure, such as it will affect your cartilages, it will affect your tendon, it will give effect to your ligament, bone, and also muscles. I mean, all of this will change all of that. Okay, and by understanding all of this type of mechanical load, it helps you to actually enhance performance and at the same time prevent and also can use to evaluate causes of injury. Ini fungsi topik ini sebenarnya. Okay. By knowing all of this, you can prevent injury. Satu. You can know the cause of that injury. Kedua. And yang ketiga, you can evaluate in order to overcome all of this injury. Okay. So, to divide the mechanical loads, we can divide that um, into two. One is known as stress. Ni semua ni yang kita nampak ni, nama dia stress. And by having stress, we are going to have strain. Okay, we have stress, we have strain. Dua benda. And these two things works equally with one another. Saya tengok dia punya graph dulu. Because when you have strength, when you have stress, you have strain. Dia takkan ada satu je dapat stress, strain tak ada. When you have stress, you have strain. Dia akan dapat dua-dua sekaligus. Alamak, sekejap. Kenapa buku saya beralih? Why my books change? Okay. Okay, so kamu akan dapat something yang begini. Ni untuk intro lah dulu. Okay. If we take stress and strain into graph, stress and strain. Okay. Nak faham dia senang je. Kalau kita ada satu objek, let's say this is your long bone. Okay, we assume this is your one of your long bone, such as maybe your femur, maybe your humerus, maybe your radius ulna, or maybe your tibia fibula. Either one of it. Stress is something like this. Force that been inflicted in this form. Okay, kita namakan dia sebagai force A. This is stress. Okay, while strain is this one. FB. So if we compare these two things, if we apply stress to your long bone, katalah ni long bone kamu ni kan, dia punya panjang 10 cm. If we apply stress, dia akan jadi macam ni. Okay, sekejap saya betulkan sebelah lagi. So instead of 10, mungkin dia dah jadi 9.8 cm. So it bulges, dia mengembang. If we put a stress to the bone, ni stress. But if we put strain, it will be like this. Okay, tadi 10 kan, now it become something like this. Macam ni lah. So instead of 10, dia mungkin dah jadi 10.1. So we are going to get some narrowing at the long end, at the shaft. Ni kalau kita undergo strain. Ini kalau kita undergo stress. So every single time in everyday life, our bone subjected to these two. Okay, sometimes it's subjected to stress and strain in a different period of time. Sometimes at the same time you are affected by those two simultaneously. Jadi yang berbeza cuma place. Okay, cuma place. Okay. So if we visualize stress and strain in our body, the interrelation between these two is actually linear. You increase stress at one point, you are going to get strain at another. You increase strain at one point, you are going to increase stress at another place. Ini adalah apa yang terjadi dekat dalam badan kita setiap masa. Because our body, okay, katalah kita ambil kita punya tulang femur kan. Okay, this is the shape of our femur. So we have femur head. Our body is not subjected to force like this at any given point of time. Bukan daripada satu arah. but it is actually from multiple direction. Due to that, let's say kita berdiri, okay, kita berdiri. Okay, this is your pelvic. So when you stand up, most of your body weight is going to move that way. It's going to move down to the ground. Okay, jap. Padam dulu. Okay, it's going to move down. This is your pelvic. This is your femur. Okay, so when your weight is going down towards the femur, there will be multiple direction of force acted upon that time. It will move down, it will move inwards. Okay, it will move down, it will move inwards. So when a force moving down, this is quite linear force, or we call it as eccentric force. The effect is compression, compress, ataupun stress. Okay. At the same time, you also have a force acted through the head of the femur, which is not linear with the femur, but axial. So this kind of force is known as eccentric force. Okay, centric force cause linear movement. Eccentric force cause angular movement ataupun torque. So when this is a torque, it cause the bone to have some sort of movement axially. At the same time, centric force cause a compression. Okay, so kita ada compress at one point, we have strain at another, which cause the bone to actually bend. Okay, which cause the bone to actually have some sort of bend, but ini kita visualize lah. The bone is not bending like this, but the force makes the bone to have those kind of bend. Force and there. So at here, you're going to have the most stress. At this part, you are going to get strain. That is what it means by this graph. At any given point of time, our body subjected to those two, stress and strain, and the relationship between those two is quite linear. Okay, it's quite linear. Ini concept lah. Okay, this is just a concept of that. Okay, so let's go to the first three type of mechanical load. Dia ada nama dia. Let's see. Okay, compression. Okay. Feed width. Sekejap Okay, next one, before we go here, if we try to quantify, okay, we try to quantify all of this. The equation is this one. Okay, kita ada satu bulat. Macam tu. Macam whistle. This is known as sigma. Okay, sigma equals to F over A. F is force and A is area. So force is in Newton, area is in meter square. Okay, contoh lah. Kita ada tulang belakang. This is our spine. So we try to determine how much load every column of the spine subjected to. If let's say the person weight is 550 Newton and the area of the perforated disc is 25 centimeter square. Ini size dia. Jadi berapa banyak load yang setiap disc ini tanggung. So you are going to do sigma equals to force over area, and this area need to be in meter square lah. So kalau 25 centimeter square, it is 0.025 meter, meter, it will be 0.25. 0.25 meter square. So we have 550 over 0.25. Apa kita dapat ini? 550 over 0.25, 2,200 Newton per meter square. Ni dia punya tekanan, okay, for every single part of the vertebra. Ni contoh dia lah. Okay, ke 1 cm. Oh betul lah, saya terlebih perah pula tadi. It's not this one, it is 0.025. Okay, so you are going to get 220. 550, 0.025. 550 over. Sekejap. Dia dah betul disalahkan. Ni. Sekejap ya. 1 centimeter square equals to 1 meter square. 100. 1 meter. 100. Okay. Sekejap. 10,000. Okay. Right, so there will be 25 centimeters square. 5 times 5. 0.5 times 0.05. Alamak. 0.05. Okay. So 25 centimeter square is 0.0025. 0.0025 meter square. Okay, so we have 550 over 0.0025. 550.0025 kita ada 220. So the answer itu 2000 1 2 3 4 Newton meter square ataupun 220,000 Pascal. Ni yang tekanan lah. Okay, this is the amount of stress for subjected to each peripheral. Siapa yang baru masuk tadi dah masuk belum? Saya tak sempat tekan lagi. Okay, ni contoh kalau kita nak tengok tekanan dia. So the formula for that will be sigma equals to force, internal force over area, and this area need to be in meter square. Okay, meter padu. Okay, so bila kita nak tukar sentimeter padu kepada meter padu tu, please take a look closely lah. Kalau kata kita tukar sentimeter ke meter, it will be 1 meter equals to 100 centimeter. Jadi kalau kita tukarkan kepada padu, okay, contoh macam ni. So you have 100 centimeter here, 100 centimeter there. This is centimeter square. Okay, untuk 1 meter padu. So 1 meter padu, 1 kali 1, it will be 1 meter padu lah. But when it goes to centimeter, it will be 100 to 100. Okay, 100 kali dengan 100. So for 1 meter square, you have 10,000 centimeter square. Dia punya perumpamaan dia lain sikit. Dia perumpamaan bukan totally linear 1 meter equals to 100 centimeter, but it will be 1 meter equals to 10,000 centimeter square. It will be 100 centimeter kali dengan 100 centimeter. Jadi 25 centimeter, it is 0.0025 meter square. So the total internal stress you have for every single disc is 220,000. Okay, Pascal ataupun 1000 Newton per meter square. Okay, so kita tengok lagi satu example, contoh macam ni. We have a biological material. Let's say lah kita ada satu sampel batu buah pinggang. Okay, we have kidney stone. Okay, we have kidney stone. So the cross-sectional area of this kidney stone is 1 centimeter square. Ni cross-section dia. 1 centimeter means 1 centimeter kali dengan 1 centimeter. So you have 1 centimeter square. Okay, if this machine apply a tensile load to the specimen until it fail, maksudnya we apply satu load kepada ni sampailah dia pecah, and the maximum force applied, okay, maximum force applied was 700,000 Newton before this kidney stone start to shatter. So the question is, what is the maximum stress? What is the sigma? What is the maximum stress this kidney stone able to have? Okay, itu yang kita kena cari. Okay, so we have sigma equals to force over area. Okay, and this area need to be in meter square. Tu kena cari dulu meter square dia. Right. So after you have find out the meter square, you can substitute everything into the equation. 0.0001, 10,000 tadi kan. So the answer for this will be 7, 1, 2, 3, 4, 5, 6, 7, 8, 9. 7,000 juta, or it will be 7 billion Pascal. Okay, or we can come up with 7 giga Pascal. Tu tekanan yang dia mampu tahan, okay, before it start to shatter. So dekat bila kita cerita stress ni kan, when we talk about stress and strain, you need to have this conversion tu elok-elok. Conversion dia kena betul dulu. Kalau tak nanti kan dia jadi ke laut. Okay, pasal kita selalu ingat 1 meter is 1 centimeter, 1 liter is 1000 milliliter. But when we talk about luas, dia ialah lebar kali panjang. So kalau 1 meter square of this one consists of, okay, if this one is 1 meter square, means it is 1 kali 1. 1 meter kali 1 meter. But when we have the unit in centimeter, it will be 100 times 100. 100 centimeter times 100 centimeter. Jadi jawapan dia ialah 10,000. Okay, 10,000 centimeter square equals to 1 meter square. So when you do conversion, make sure the conversion is true, is correct first. Or else nanti jawapan dia lain lah. Kamu akan dapat nombor depan ni betul, but nombor belakang dia kurang. So that resemble quite a false amount of strain. Tu kena ingat yang tu je. Yang lain semua calculation dia simple je. Okay, that is how we want to quantify stress. So what kind of stress we may have from our mechanical load? So the first one, okay, these three, compressive, tensile, and shear, is known as principal stress. Three principal stress, maksudnya bentuk stres utama. Okay, bentuk stres asas is this three one. The first one is compressive, the second one is tensile, the third one is shear. So compressive stress or compression is stress that being subjected to you in term of squeezing, in term of tension. It's not tension here. In term of compression, in term of stress. tekanan. Okay, so when our bone or our body undergo a compression, just like what I have visualized earlier, we are going to lose some length. Panjang kita akan sedikit berubah, and by losing the length, we are going to have some bulges. Okay, compression. Ini adalah principal stress yang pertama. Okay, principal stress yang pertama. So if we have, let's say this is your bone, 10 cm. So after compress, it will lose some length. Maybe become 9.98, and then you are going to have some sort of bulges. So the molecule being subjected out, especially at the area where it is not so solid, at area where it is not so hard, so it will be bulges out. Jadi macam tu. Ni compression. So the force will be subjected to one another, causing part or an area to bulge out. Sama macam kita beri tulang belakang. Okay, we have tulang belakang, we have this, our vertebral disc. And when our bone subjected to a compressed stress, you standing up. Contoh paling utama, you standing up. So what happened is, the bone is still there, but since the disc is not solid, the disc is permeable, the disc is elastic, it will bulge out. Dia akan jadi macam tu. Okay, and then you have your bone, and then the disc bulging out, and then your bone. Macam itu. Tadi kalau kata 3 bone and disc ni 30 cm, now it become 29.5. So you lost 0.5 in those bulging out. This is compression. So all force being subjected to an area, which cause the cartilages to change in shape. If the cartilages had fully changed in shape, now the stress will be subjected to the bone itself. Ni yang pertama, compression. Okay, so how we want to measure how much compression occurs at every single part of this disc is by using sigma tadi. Sama je. So how much force, how much area involved. So compression is a pressing or squeezing force directed axially through a body. Jadi weight cause compression. Ni yang pertama. Okay, yang kedua is, call it, tension ataupun tensile. Ni yang kedua. Tension ataupun tensile. So tension or tensile is actually a pulling action. Okay, it is a pulling action that pull apart all the molecules. Okay, it pull apart all the molecules. Means it makes your bone density less. Tak adalah less density tu maksud macam mana? Kita nak cakap macam ni. Okay, macam ni. Kita ada, this is our bone. So our bone consists of molecules. Okay, it consists of several molecules. Pack. Kalau kata kita tengok gases, the molecule is separated. If we take a look at water, the molecule is denser compared to gases. This is solid, gas, fluid. So these are the molecules within that, within the same size and shape. So what happened when your body undergo a tensile ataupun tension, okay, ataupun strain. These three name is actually a single force which acted like that. Force keluar, which make the area between those molecules start to be, you're going to start to have an area. Okay, notice that in chemical bonding, all of this molecule is actually connected to one another, and it has some sort of energy connected with one another. If your force, your tensile is too much. Okay, if the tensile is too much, this bond is going to break and you're going to shatter your bone. You're going to get injury if the tension is too much, if the pulling action is too much. So bila pulling action too much ni, kalau kita cerita tulang, okay, for example, we take our hand. Okay, we take our hand first. So it consists of your ulnar radius, it consists of your phalanges, it consists of your humerus. And then this humerus will be connected to the acromion process of your scapula, connected to the clavicle, and then it is connected to your ribs. So all of this, bone to bone, it is actually being connected by some sort of cartilages. Okay, it is connected by some sort of cartilages. And this cartilages is known by the name of ligaments. Itu satu. Yang kedua, there are muscles connected between bones and bones. And this muscle being attached with another cartilages known as tendon. Okay. So, if we subjected a strain, if we subjected a tensile stress, if we subjected a tension, means we pull. Contoh paling mudah, kita bergayut. Kita bergayut. Okay? You hang on monkey bar or whatsoever. So, the force within the system is going to pull top and bottom. So, kalau kata tulang kita tu kan, okay, kita ambil ni, your radius and ulnar. So, when you subjected this bone to a tension, what is going to happen is this bone, it will being subjected to a pulling force, which make the molecule within the bone to try to be separated. So if this bone in starting is 10 cm, now if you do a very minute measurement, it will be 10.003 or 4 or 5. Means we are going to have increment in terms of length because that bone been subjected to mechanical stress, and the stress in particular is tension, tarikan. So what happen if we keep on giving this tension? So you are going to rupture all of those soft tissue first because it being subjected to a strain beyond their capability or beyond their threshold, which make their ability, their elastic ability or ability to return back to original condition out of order. So it will break. But if the tension is still within the limit, it will return back to normal. Okay, jap saya bagi satu contoh mudah. Okay. Please observe me. Okay, tengok. Nampak tak ni? Can you see this paper clip? Do you have paper clip? Ni kita nak tengok tension. Nampak? Can you see this one?
Nampak sir.
Nampak. Okay. Tengok Kalau kita tarik this paper clip ke satu arah, okay, we pull this paper clip and we release that. This is tension. Okay, this is tension. Same goes as your muscle. This is tension. We apply a force in terms of tensile and then we release that. It will return back to normal condition. Dia kembali kepada bentuk asal. But what happen if we pull or if we apply tension beyond its capability? Ini yang jadi dekat muscle kamu. It won't return back to normal because of tension. So by knowing this, you can actually prevent this to happen. Macam mana kita nak elakkan injury in terms of our muscles, in terms of our tendon and ligament, and finally in terms of our bone itself. Don't go beyond the limit. Why this happen? because of mechanical load known as tension. So how we want to quantify tension? Sama je dengan formula tadi. We go with sigma. Okay. Jadi dia akan memanjang. Cuma bila kita dah when our bone is when our ligament had already torn and you still keep pulling, so the tension actually being contained by our skin. Okay. Kalau tulang kita yang di stretch and tarik, and then you're going to get effect towards the bone itself. Ni macam contoh. Okay, contoh example, we have low back pain patient. Okay, patient yang mengalami low back pain, which some of them, especially those who have problem towards their sciatic nerve, okay, most of the time that nerve being pinched by your bones, by your cartilages, nerve being pinched. So you have a tingling and towards some extent a very painful sensation at your lower peripheral. So when you go to rehabilitation, the first thing that they are going to do is actually to stretch you up. They are going to strap your hand and your ankle, and they are going to pull you through. Dia akan tarik kamu. They are going to subjected you to tensile. So that all those part is going to be elongated, and hopefully the pinched nerve is out of the way. Tak selalunya jadi. Ni apa yang kita boleh buat. Okay. This is how we manipulate mechanical load. Okay, let's go back to our notes. Right. And ni tension. Tu. Okay. So kalau kita tengok bentuk ni, bila kita bagi tension, kita akan dapat sedikit elongated. And then if you take a look diameter dia, lebar, diameter yang ni dia jadi lebih nipis. If we compare to this one, diameter dia kecil, yang ni dia jadi lebih lebar. So the more elastic the parts, the more elongated in terms of diameter you're going to have. Okay, so tension is pulling or stretching force directed axially through the body. And the third one, the third principal stress is known as shear. Okay, shear. Shear act parallel. Yang dua ni tadi act axial. Okay, apa beza parallel dengan axial? When you see axial, okay, bila dia kata axial force, if this is your bone, axial means follow the direction. Kalau bone kamu macam ni, this is axially. Kalau bone kamu tegak, this is axially. Tak kisahlah, regardless of the direction, but it will follow the direction of the bone. That what it means by axial. Another type of force is a force that being given like that. This is known as tangent. Force that being given in terms of tangent means it being given in parallel. It being given, what we call it, in parallel lah. In parallel. Contoh macam ni. Contoh shear force. So if we take a look at shear force, this force being subjected parallel ataupun tangent, berkadar lurus dengan tulang kita. So if our bone is like this, kita punya femur, and the force being given like this is known as tangent. If our bone terbaring macam ni, it will be anterior posterior. Kalau bone vertical, it will be mediolateral. The force is tangent. The force berkadar lurus dengan tulang kita. So this is known as shear. Okay, this is known as shear. And shear force, when we subjected this to, kita nak faham ni, kita tengok benda macam ni. If we have one object, okay, two object, we put two blocks. Okay, we put two blocks side by side. Block A, block B. And we apply force. It will cause block A to go down and block B to go up. Okay. Now, imagine block A and block B being snapped together. And we apply the same shear force. It will make deformation. Macam ni. It will make the block to deform. Instead of being square, now it being diagonal. And if you increase or go beyond this threshold, you are going to break the block in half. And that break is actually caused by torque. Okay, one torque. Ni satu je lah torque. Satu ke bawah, satu ke atas, satu torque. Kalau dua torque, maksudnya dekat sini ada atas dan ke bawah. Dekat sini ada atas dan ke bawah. This is dua torque. Okay, so it will cause one part of the bone to rotate that way, another part of the bone to rotate that way, different rotation, and this is known as torsion. Torsion ni upgrade level of shear. Okay, shear only caused by one torque. Ada satu object being subjected to two force from different direction tangentially. If this part have axis of rotation, it will rotate. But since this part is actually apart from much longer part which does not move in angular motion, means it move in term of linear, it does not have joint, and we subjected a torque or a shear force to this object, which will make this object to deform, berubah bentuk dia. And if we continue giving that kind of force, it will rotate and it will break. For example, okay, okay, Muhammad ni tengah berlari ke depan, okay, go that way. So the force being driven this body is that way. And somebody, somehow, a good fella, parap kaki dia that way. Ni shear force. Apa jadi dekat tulang keting dia? What happened to this part? Ada lagi tak part tu? Okay, ni siapa main bola ni? Apa jadi dekat keting dia? If Mamat ni running to the goal and somebody from the goal tackle dia daripada depan, means we have two different force acted simultaneously but from different direction to a body part which does not have joint. Mean that body part only go linear, it does not go angular. What happened to the part? Apa jadi kat kaki ni?
Patah.
This is shear force, and our body is good at compression, less good at tension, and worse at shear. So if you give shear force to a part that is only subjected to translation, patah is imminent, confirm. Okay. Itu shear force, or the third principal type of stress that always subjected to our body. Force directed parallel. Compression and tension, force acted in term of axial. Ini kita panggil sebagai principal. Okay, this is known as principal stress. Okay, this is known as principal stress. Okay, and then after principal stress, we have another type of stress, and this is much complicated. Okay, this is much complicated type of stress. Okay, because in human movement, most of our stress is actually multiple stress works together simultaneously. Kita bukan subjected pada compression pada satu-satu masa, tension pada masa yang lain. No, but at any given point of time, most of it, we are subjected to multiple stress. Okay, so the first type of complicated loading is known as bending. Okay, so our body subjected to bending a lot. Okay, a lot. Okay, now take a look at me again. Okay, example, this is your humerus, tangan. Okay, ataupun this is your tibia. Okay, this is your tibia. Okay, if you give force, okay, if we assume this is the what we call it, Dia ada nama lah kat sini. Ada analysis plane lah. Kita nak tengok dekat sini. So if we apply a compression to this analysis plane. Okay, kamu buat, siapa ada pensel yang dah tak pakai tu boleh buat macam ni. This is bending. And what happened during bending? If we apply a compression towards the analysis plane antara saya punya thumb dengan thumb. In order to apply an analysis a compression towards analysis plane, saya punya index finger 2 ni, it will produce a tensile ataupun a tension. Okay, so now we have multiple force acted upon a plane. Satu ke atas compression dan dua ke bawah. If we move through this plane, what happen is you're going to see bending. That is what happened to your bone. And if you go beyond that, it's break. Okay, itulah apa yang selalu terjadi dekat badan. Because when you stand up, bila kita stand up, we apply compression. And that compression is towards the center of mass of that particular bone. So if your bone is femur, contoh kan, ini lutut, ini pelvic, so this is your femur. The center of mass is in the middle of that. So if you stand up, most of the compression is going to subjected to that particular center of mass. Okay, itu satu. Dan yang kedua, bila kamu mengalami kecederaan trauma, maybe you being tackle, you being you collide with one another. So the amount of force, the type of force subjected to that bone is going to be different, and you are going to be subjected to multiple mechanical loads. It depends on from where the origin of the force. So let's see, compression ke tengah, and then you being subjected to something from medial, daripada luar. So that will cause that will compress this bone to that side. At the same point of time when this happen, the middle, in order to counter that action, it will cause a reaction to that side. So you are going to get benda macam, okay, femur, force acted medially, and at the same time we have compression, which this will act as the counter reaction. So your bone is going to be something like this. Bila dia jadi macam itu, okay, bila dia bend macam tu, apa yang terjadi? Pensel ni pun dah tak nak bekerja dah. Pensel tadi dah mati. Okay, you are going to get something like this, where in here, this part is going to subjected to compress. This part, however, is going to be subjected to tension. So this part is compressive, this part is tensile. So that are the part that is going to have the most effect towards fracture. Jadi human movement most of the time is because it is a combination of stress and loads. It depends on where the force being subjected to. Okay, where the force, from where and how much. If the subjected force is still within the threshold of your bone, and you're going to be safe. If it is not, and then injury is going to happen. So you need to avoid those kind of action. Okay, action from multiple loads yang kita tak boleh nak control itu. Ini penyebab dia lah. Okay, so the first type of complicated mechanical loads is known as bending. Okay, so one part of the bone is going to be compressed, another part is going to be tension ataupun tensile. Asymmetric loading that produce tension on one side of the body and compression on the other side. Ini yang pertama. Yang kedua is Weh, asal gambar dia jadi kecil. Is known as torsion. Sekejap, nanti saya lukis balik torsion. Okay, this is known as torsion. Sekejap Torsion. Okay, torsion. Alright. So torsion is load producing twisting of a body around its longitudinal axis. Okay, so apa itu torsion? Kalau kita tengok dekat sini, torsion dia macam ni. Okay, remember again what I have discussed before this. Shear tadi. Okay, shear. Where we have force like this. Okay, and we know based on our mechanical basis of human motion, when we have force from multiple direction, this will cause a rotation. However, ini tidak ada axis of rotation and this part cannot rotate. Jadi dia akan shattered. Now, when we talk about torsion, sama je, yet this one, the force being subjected linearly. Torsion, the force being subjected. Macam mana kita nak buat dia ke depan? Macam ni. Satu ke belakang, satu ke depan. The force being subjected in term of torque. So maksudnya dekat sini akan ada satu force ke depan, satu force ke belakang. Dekat sini akan ada satu force ke belakang, satu force ke depan. So we twist that. Which make your bone to crack. Lagi teruk daripada shear. Okay, so contohnya. Okay, contoh. Macam mana kita tengok shear dekat dalam badan. Torsion dekat dalam badan. Okay. Kita ambil tulang femur tadi. Okay, we have femur. And then we have femur head. Okay. So when we stand up, this femur head, it will have force from the weight. Okay. That is force from the weight. At the same time, when you move, you are going to subjected another force. Sekarang kita ambil dia ni je. Okay. So when this happen, okay, satu force pada bawah, satu force pada atas. Kalau kata kita besarkan femur ni and we try to measure the length, okay, gambar tu dia akan skewed macam ni. Ini kepala femur. Means that here you are going to be subjected with compression. And to the upper part, you are going to be subjected to tensile. Here you are going to be pushed downwards. At the same time, there are another force acted to the head of femur. Okay. And this is the major reason why people start to have crack at the femur head. Because the amount of force being subjected to this area is quite enormous. Okay. It is quite enormous. And the area being subjected of force from multiple direction. So dia dapat torsion, especially to an area which is rotating lah. Kalau area yang tak rotate, dia lagi banyak effect dia. Contoh macam ini. Okay, contoh macam ini. When we have torsion macam ni. Okay, macam mana kita nak dapat torsion macam ni? You run forward and you try to change direction tapi kaki terlekat dekat atas tanah. Badan berpusing, kaki tak pusing. Okay, you run forward. People, okay, running forward. Oh, siapa ni baru masuk? Okay, people running forward. And then sampai sini kita nak cuba untuk pergi ke sini pula. But our leg stick. So you're going to get torsion. Badan rotate the femur to one side, but the kaki is towards another. So if that is quite large, the torsion is quite large, what are you going to get is a shattered bone. So that is the reason why it happened lah. Kenapa kaki kita lembik dan patah. So our body is good at this too, but not good at others. Okay, yang ini adalah compression. We have both torsion and bending. Contoh macam tadi kita nak bertukar arah, at the same time kena scrum. Dah, tak payah cakap banyak, confirm patah. Okay, you try to change direction, boot tersangkut dekat atas padang, so your leg pointing other way, your body pointing the other way, and then somebody tackle you from an awkward position. Contoh kita dah pandang depan, kaki medial, dia attack daripada lawan medial lateral. Pom, patah. Because your body subjected to both, the leg is subjected to both torsion and also bending, which is a complicated type of stress, and it will make your body to break. Okay. Lagi satu contoh torsion ni kan, bila kita nak cerita torsion ni, a smaller amount of bones, okay, regardless of the placement, if you have, contohlah femur macam ni, compare lah dengan tibia yang macam ni, okay, where the area, okay, kalau kita potong ni, dia punya analysis spleen ni, the area is smaller, the ability to sustain torsion will be lesser. Lagi kecil tulang tu, lagi kurang ability dia untuk overcome torsion and bending because of area dia kecil. Okay, tu konsep dia lah. That is the concept of our mechanical loads. Okay, the topic that we have, that we discussed today. That is the concept of it. Okay, ini tak ada apa. Alright, before we end our class, okay, ini contoh kan, kita tengok beberapa contoh mudah saja berkenaan dengan stress. Okay, so the first example, okay, kita ambil example yang ini. Let's say this is your lumbar. Okay, this is your lumbar. Okay, let's say 56% of your body weight being subjected or being supported by the lumbar. Okay, by the fifth lumbar vertebra. How much stress presented, okay, how much stress presented within the lumbar if the area, the surface area of the lumbar is 22 centimeters square and the weight of the body is 756 Newton. Okay. So, saya bagi lagi satu contoh. Saya bagi satu clue. Okay. I give you a clue. Alright. FA. If the calculation involving centimeter square, you can actually stick with centimeter square. Does not need to change to meter square. Jadi, nombor dia takkanlah dapat berjuta nanti. So, for this one, okay, mechanical stress equals to force over area, where the force is 756 over 22. Macam tu ke? Bukan. We need to include percentage first. Maksudnya, hanya 56% of total 756. So, it will be 756 times 0.56 first. Barulah kamu bagi dengan 22 and you are going to get the answer. 0.56. Okay, it will be 423.36 divided by 22. We have 19.2 centimeter square. Inilah tekanan setiap disk ni terima. Okay, ni contoh pertama. Okay, soalan kedua. Based on this answer, okay, based on this answer, what happened to the amount of stress if this fella lifting up a barbell weight at 222 Newton. So we need to add on another 222 Newton at the equation. Berapa pula beban baru dia kalau dia angkat 222 Newton bebanan? What is the new stress being subjected to the vertebra if the same fella lifting up a barbell weight at 222 Newton. Okay. Berapakah? Adakah kita akan tambah pada 756 atau kita akan tambah dekat ni?
Dekat 56%.
Ha?
56% of the ni kita tambah dengan 222. Is it?
Tadi 56 ni kita dapat apa? 423.35 kan?
Uh-uh.
423.35 kamu tambah tu. Dua-dua. Because
Okay, betul.
the question is still based on the original weight. Okay? Dan dekat 756 tu tambah tu. Dapat jawapan ni barulah bagikan. Dapat? 29.3.
Dapat.
Okay. Right, next question. We talk about impact force. Compressive lah. Okay, we talk about compressive force. Okay, let's see when a person stand up. Okay, bila kita berdiri, so there will be weight and there will be compression. Okay, katalah, okay, if an impact force of the foot, impact pada kaki ni ialah 1875 Newton, and this impact being reduced by 15%, okay, by the tissue at the ankle joint, and another 45% by the by the tissue at the knee joint. It being reduced, okay, 45% here, 50% there. So the question is, how much impact force transmitted to the femur? Okay, bila kita berdiri, so the ground reaction force noted to be 1875 force there. So we assume that 1875 will be transmitted to the femur. However, at the ankle joint, it was reduced 15%. At the knee joint, it was further reduced at 45%. So what is the final amount of force being transmitted to the femur? Berapa dia dapat? Okay, ni clue dia. Force transmitted, total force transmitted is 1875. Sorry, force transmitted pula. Force of the impact. Force transmitted. Okay, force impact. So force transmitted, ni formula dia. It will be force of impact, okay, minus force of impact timeskan dengan reduction. Oh, terlajak. Reduction. Also it will be 1875 minuskan dengan 1875 times 0.6. Kenapa 0.6? Campur dulu. Dapatlah 60%. So the answer is equals to force transmitted. So 875 kali dengan 0.6, 1125. 1875 tolak 1125. These are the reduction. Okay, these are the reduction that occurs. So the total, the balance will be 750 Newton. Dapat?
Dapat, sir.
Okay, so force impact tolak dengan reduction, and then you're going to get balance. So balance tu lah dia punya force transmitted to the femur. Tadi kita dapat 1875, sampai dekat femur hanya 750 Newton. Okay. Alright. Next one. Okay, kita ada tangan. This is your axis of rotation, and then we have the bicep brachii. Okay, the question is how much compression is exerted on the radius of the elbow joint when the bicep brachii oriented at 30-degree angle to the radius exert a tensile force. Okay, maksudnya we have force move that way. This is tensile force 200 Newton. Okay, force. And the angle of attachment here is 30 degree. Okay, the question is how much compression exerted? Berapa banyak compression exerted here if the tensile force is 200 Newton and the angle is 30 degree. So kalau kita keluarkan dalam bentuk teorem Pythagoras, 30 degree, this one is 200 Newton, dia nak tahu force kat sini. This is your elbow, this is your bicep, this is your compression. Okay, pergerakan siku tu tadi tu, berapa banyak exerted force. So based on here, berapa kita dapat force dia? Macam mana kita nak tahu force kat sini? Kalau force dekat sini, kita pakai sin. Kalau force dekat sini, kita pakai cos. Okay, sin apa sin opposite hypotenuse, cos ialah adjacent hypotenuse. So we have the hypotenuse. Sekarang kita nak tahu bahagian ni A, ni bahagian ni O. A, kita pakailah cos. Jadi macam mana kita nak masukkan? Ni straightforward je. F A equals to 200, okay, 200 cos 30. Dapatlah kita berapa banyak compressive force dekat radius. So dekat radius tu, kat kita punya radius ulnar lah. Dekat radius ulnar kita, tu lah radius dia. Radius of the elbow. So kalau kata putaran ni, dia putar kan, ni lah radius dia. So kita dapat 200 kali dengan cos 30. We go with 30 trigonometric cos times 200. 173.21 dapat?
Dapat.
Alright. Inilah cos dia. Kalau dia tanya berapa banyak perpendicular force, tadi kita bagi force macam ni kan. Okay, contoh kan, kita ada macam ni. Okay, this is your axis. So this is force. Dia tanya berapa perpendicular. Perpendicular bahagian ni, selari. Berapa perpendicular force, pakailah sin. Okay, kalau dia tanya force dekat radius, pakai cos. Bila kita nak cari adjacent part, cos. Bila kita nak cari opposite part, pakai sin. So kamu akan ada 200 Newton sin 30. Itu je beza dia. Okay, comparing opposite dengan adjacent part. Okay, next one. If the anterior and posterior deltoid, deltoid depan dan belakang. Okay, so kita ada acromion process, we have the trapeze, we have the scapula. Okay, we have the head of the humerus and the humerus itself. Alright, now if the anterior and posterior deltoid, okay, these two deltoid. if the anterior and posterior deltoid insert at an angle, so both have an angle theta equals to 60, yang ini pun sama, theta equals to 60. Okay, both of the deltoid insert at an angle of 60 on the humerus, and each muscles produce 100 Newton. Soalan dia, how much force is acting perpendicular to the humerus? Okay, so kita ada dia macam ni. Pak dia dah sebut dah, perpendicular. So dia nak tahu yang ini. So we have 60 and both work at 100. 100 degree pula. How much opposite? So kita akan pakai sin. Okay, senang kan, kita akan pakai sin. So kita ada 100. Okay, force equals to 100 Newton sin 60. Berapa dapat tu dulu?
Lapan
6.6
is it?
86.6 kan? Okay, kita dapat 86.6. But dia cakap tadi ada berapa muscles? Posterior and anterior. Gila dua. Ini cara lambat dan lembab 173.2. Cara cepat dia, kau tambah je 2 kat depan ni dapat satu equation dia. 2 kali 100 Newton. Ni selesaikan je ni. Sin 60. Dapatlah sama jawapan dia. Okay. So this,
Sir, dia memang ambil one decimal point lah.
1 boleh, 2 boleh, tak ada masalah. Nak buat 1 boleh, nak buat 2 boleh, nak buat 3 boleh. Tak nak buat decimal point pun boleh. Kalau tak buat decimal point, dia end up 173 je. Kalau tak, dia 173.20 kan. Kat belakang ni kalau saya tak silap.
21.
21. Sama je, tak ada masalah. So kalau kata soalan nanti keluar lah macam ni, kamu terlupalah decimal point ke apa ni, setakat plus minus 1, 2 tu, I'm not going to penalize you lah. Itu standard error. Tapi kalau 173, jawapan kamu 170, masalah lah. Okay? Alright. Okay, so that's all for our discussion today. This one is just about concept of stress and strain. So just remember, stress is compressive, strain is pulling. Okay, and as the definition of force, it is actually a push, a pull, or a blow. Okay, a blow. Or in other words, we can actually define force as any kind of energy being subjected which cause changes. Changes in terms of place, changes in terms of acceleration, changes in terms of shape. That is force. Okay, so the principle of force, we have 3, which is compression, tension, and shear. Okay, the first 2 is work axially, and the last one works tension. And complicated type of force, we have a bending, combination of both tension, combination of compress and tension, and we have torsion when we apply two torque towards a system which every single torque works in different direction. And finally is multiple loads, which is a combination of both bending and torsion at the same time. So why we need to know this is by having the knowledge of all of this mechanical load, we can actually prevent injury. We can actually mix the what we call it, the technique become much better, and we can excel much faster with that. All right, so that's all for our class today. Again, don't forget to make your revision up until chapter 5, which is regarding work, power, and energy. You are going to have 10 multiple choice question and 5 to 6 short essay. Oh, sebelum saya lupa tadi kan, ada satu benda yang saya cakap saya nak bincang akhir, which is regarding modalities. Okay, this is also a concept you may search through later. In biomechanical analysis, kinematics ke, kinetics ke, there are multiple modalities, but the most important for us biomechanists is 2. The first one is the 2D analysis. The second one is 3D analysis. Okay, 2D analysis ni maksudnya kita buat analysis based on two-dimensional data. Okay, data yang macam mana tu? Data macam ni. Data yang hanya ada X, X terbalik dah. Data yang hanya ada X and Y. Maksudnya you can observe things in term of horizontal component and vertical component. And when we talk about three-dimensional, we add on another one, which is torque ataupun rotation. Means we able to rotate the data from whichever view that we like. Although we record that sagittally, but it can be frontal, it can be transverse. But if we talk about two dimension, if you record that on sagittal plane, that will be the final one. If you want to do frontal, you need to take another one. Okay, so modalities dia ada banyak lah. Contoh macam 2D, we use only a normal camera, we can use camera phone, we can use pictures, we can use any means which able to provide you with two-dimensional data. But if we go for three-dimensional, okay, there are certain equipment needed. For example, is this one. Ni yang kita ada dekat dalam lab lah. Saya rasa siapa yang pernah masuk semester lepas, you have seen this one. Okay, this one is known as motion capture 3D analysis system. Kita akan pakai kamera, and this camera will record all those marker, benda-benda yang berkelip-kelip kan, benda-benda yang nampak shining tu. It will capture all those marker and it will render that marker into model. Okay, cuba ada tak model. It will render all those marker into model like this. Kalau saya buat analisis, saya tak nampak, kamu dah saya nampak benda ni je. This is model, and based on this model, although we record that from this frontal plane, we can manipulate. Kita boleh tengok pada atas, kita boleh tengok pada tepi, kita boleh tengok pada bawah. We can rotate from whichever. This is known as 3D analysis, ataupun 6 degree of freedom analysis. Ini contoh, okay? Kita ada banyak equipment lah. Other than this, we can actually use initial sensor. Okay, initial sensor. Ada tak contoh dia? Sekejap ni contoh. This is an example of initial sensor. So, this one they combine, but we can actually leave out all of this marker. Ni marker ni kan kita boleh buang lah. Kita pakai sensor saja. So, the sensor will determine where are you, and they will come out with a model. So, kita tak perlu lagi pakai marker. This is known as initial sensor. Okay, tadi 3D analysis based on optical. This one is 3D analysis based on initial sensor. These two is the most common 3D methods. Kalau 2D methods, banyak. Contoh paling mudah, benda yang kamu kena guna masa presentation, group presentation, Kinovia. This is an example of 2D analysis. So based on pictures that is static in term of plane. Video bergerak tapi plane dia sama. You can do analysis. So cerita dia, now we do analysis for flexion extension. Can we actually see bending? Kita nak tengok pada frontal, tak boleh. Because it only permit you analysis from X and Y, and it does not involve any rotational or torque. Ini 2D analysis. Kita ada Kinovia, kita ada yang ini pun saya pernah pakai di tracker. Alamak, ini motor analysis. Ni di tracking. So dia sama je macam Kinovia, but this alamak kecilnya. Sorry. Tapi yang ini lebih pada physics and engineering lah. Okay, dia track, dia lebih kepada modeling. Kalau Kinovia tu kita nampak pattern. Okay, contoh dia boleh come up with this kind of equation and figures, so we can determine where it happens. Ini koordinat. They talks about koordinat. Kita ada D-Tracker, kita ada Kinovia, kita ada MATLAB, kita ada apa lagi? we have open seam. All of that is an example of 2D analysis. Okay, so itu antara kita punya analisis utama lah. We go for 2D, we go for 3D. 2D based on recorded video, 3D based on either optical ataupun inertial sensor, wearable sensor. So that is the modalities. Okay, tu je lah. Yang lain-lain tu kamu search through lah. Okay, search through, tengok apa-apa yang ada. Right, so with that, this will be the end. Okay, nanti confirmkan dekat saya bila kamu nak buat test satu kamu. So we are not going to have class on Thursday since we are going to assume that hour will be used for test. So kita cukup lah, kalau tak nanti kita terlebih pula minggu ini. Don't forget to take your attendance. If you happen to have some question to ask, you may ask me directly or you may put your question in your Google Classroom. Okay, with that, thank you again for your participation. See you again next week. Assalamualaikum and very good morning to everyone.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.